All right, we're going to look at functional notation. The input in an algebraic expression, the input in a function can also be an algebraic expression. So example 6, for the function f of x is equal to 3x minus 5. When I take a look at f of x, I read the rules. So it's 3 times the input minus 5. Where do I get the input? Well, I look towards the brackets. So the f of 4 really is, the f of 4 is going to be 3 times my input minus 5. And I believe that's 7. So the f of 4 is 7. Now I'm going to change it around. Now my input is no longer 4, it is m. Well, it's all the same. F of m is 3 times my input. Here it's m minus 5. So it's 3m minus 5 is my f of m. Now I'm going to zoom this in a little bit, and I'm going to write in f of x is equal to 3x minus 5. And right now my input is 2d. So I go the f of 2d is equal to 3 times my input minus 5. And my input happens to be 2d. So now I'm going to multiply this first term. It ends up being 6d minus 5. So far, so good. Now, this one is going to get a little bit crazier. But it's the f of y plus 2. Don't worry, because all I simply do is I take 3 times my input minus 5. That is the rule that is governing my function f. But my input now is y plus 2. This ends up being 3y plus 6 minus 5 as I multiply through. I'm going to simplify, and there we are. So the f of y plus 2 is 3y plus 1. Let's continue on. This is no longer a linear function. Instead, what we have is a quadratic. I'm just going to relabel, there's a typo here. So for the function f of x, it's equal to x squared plus 2x minus 3. So the function f of x, the first thing I need to do is take my input. I'm just going to square it. I'm going to go to add 2 times my input minus 3. So the f of negative 3 is going to be, now just to help out the sake of argument, wherever I'm supposed to put my input, I've just left blank brackets. And I can fill this in later and evaluate this. So negative 3 squared is 9, minus 6, minus 3. So the f of 3 is equal to 0. So I'm going to do the f of w. Well, I'm going to have to take my input squared. I'm going to add 2 times my input minus 3. So w squared is w squared. 2 times w is 2w minus 3. All right, I have a feeling things are going to get a lot more real very quickly. So the f of 5y. So it's my input squared plus 2 times my input minus 3. Here my input is 5y. So I'm considering the rules set out by the functional form. And now I'm just going to write 5y wherever my input goes. So 5y squared is 25y squared. 2 times 5y is 10y minus 3. All right. So here is what I think of my function, right? I take my input, I square it, and I'm going to add 3 times my input minus 3. Now my input is k plus 4. And now I need to evaluate this. So k plus 4 squared is k plus 4 times k plus 4. Plus 2 times k plus 4 is 2k plus 8 minus 3. If I'm going to multiply those things, k plus 4 times k plus 4 is k squared plus 8k plus 16. Plus, I'm going to evaluate this term, 2k plus 8 minus 3. Collecting like terms, I get 8k squared plus 10k. I'm going to add the constants together now. And I get 16 plus 8 minus 3. So 8 minus 3 is 5 plus 21. All right. Let's continue. So perhaps what we're starting to see with example number 6 is the purpose of functional notation. The equation v is equal to negative 0.08d plus 50. I wonder what v means. Well, v means volume in liters of gas in a vehicle's tank after d kilometers. So d probably means distance. So here is a great example why v of d is so important. Because the volume depends upon the distance. The distance I drive changes the volume. So I wrote the equation in function notation. I'm going to determine V600. And if you notice, my input is 600. And D is also in brackets. So really, this is determining the volume when I've driven 600 kilometers. And I can quickly do that. Now, I forgot a calculator. My apologies. But I'm just going to plug this in. So, thankfully, you have a calculator. I believe what I'm going to get after I calculate this expression, after I drive 600 kilometers, there is 2 liters left in the tank. So determine the distance, like when I say determine the value of d, and if I'm looking at example 6, that is distance, when v of d is equal to 26. In other words, my volume is 26. What distance have I driven? So I'm just going to equate 26 is equal to I'm going to take it from there. Forgot my variable. So I'm going to subtract 50 to both sides. So we get negative 24 is equal to 0.08d. I'm going to divide both sides by 0.08 negative, and that will give me my d. 24 divided by negative 24 divided by negative 0.08, this is going to be equal to 300d. So in the context of the question, I've driven 300 kilometers.